And welcome everybody to the Daily Space Weather! Today we're talking about a geomagnetic storm, an active region rising. Is it a sunspot? Also the great Annihilator. And I won't be annihilating you. I'm your host, Dan, aka smAsho. Let's take some looks at the closest star. This 335 angstrom one-day SDO browse data series of images dedicated to all of you stargazers out there. See that active region rising in the southeast? I believe it's a sunspot. We'll let you know by the end of the video. It may be late enough by then, and pardon our lateness. You'll catch a fleeting glimpse of the magnetic field. Not enough to really say for sure if it's a sunspot. Let's take a look at a diagram of the solar system. Here's what's going on in the heliosphere. And there's where things will be in a week. Here's a star chart. And the moon is currently in Ophiuchus. Yes, the constellation Ophiuchus. It's about to move into Scorpius and into Libra. I don't know if that's relevant to you or not. The 10.7 centimeter radio flux, which is the radio output of the outer solar corona, currently still at 73 solar flux units. There is the 1 year chart to put that in context. The radio flux on this is the black line. The red line is the sunspot number. And there it is through cycle 24 and into cycle 25. And we've got some delightful helioviewer movies, as usual. Here's a little fade to 171 and 304 angstroms. And here is some 171 angstroms SDO video footage. And you can make these videos yourself at helioviewer.org. Helioviewer.org. And here's a close-up of the southern hemisphere. There are some coronal holes down there, one leading that likely sunspot. We'll show you more close-ups of it at the end of the video. Here's one more just to tease you. It's 94 angstroms. And the rest of the helioviewer movies will appear at the end of today's daily space weather. And the next thing we're going to do is look at some more data. And just bear with me a minute, I'm switching tabs. All right, so the next thing we're going to look at is volcanoes. So now we're on volcanodiscovery.com. Today's eruptive list includes Sakurajima exploding. And by the way, happy birthday to Mothra. Down in Florida. Happy birthday, Mothra. Anyway, Sakurajima is exploding. It's producing a 7,000-foot ash plume. Suwanosejima, 4,000-foot ash plume there as it explodes. Raung in East Java. It's not wrong to say Raung. Flight level 140, it's a 14,000-foot ash plume as it explodes. Popocatépetl is exploding in Mexico. 20,000-foot ash plume above that caldera. Sangay exploding. Flight level 190, and Sabancaya is producing intermittent puffs of volcanic ash. Please do not attempt to do a double backflip layout with a half twist over the caldera. Largest earthquake of the past 24 happened here north of Papua New Guinea. It's a 6.3 magnitude. In the Bismarck Sea. And let's just check tsunami.gov real quick. I thought my browser would have remembered that site. Originally reported as a 6.6. No tsunami threat likely from that earthquake. A destructive Pacific-wide tsunami not expected. And let's go to the list here. By the way, that happened today, just 45 minutes after midnight at 0:45. So we're just going to scroll up the list here. And again, the 7, 8, and 9 magnitude earthquake drought continues, folks. I'd prefer to not say it every day, but earthquake droughts end in large earthquakes. Although I can't guarantee that. So here's a deep quake at Bolivia. Here's a deep quake at Japan. And there's actually a swarm of quakes there. In Western South America, you can see a whole slew of quakes. We'll zoom in real quick on that area. And you can see some quakes in Bolivia, Argentina, and Peru. Not Peru, Chile. But no large quakes. And let me zoom back out here. That deep quake, by the way, is at over 350 kilometers. There's a deep quake at Tonga. A 5.0 at 369 kilometers, and then a 4.9 coming in about a half an hour later at 154 kilometers. So 2 deep quakes there around Tonga. There was also another 6.0 that happened near the Philippines. Check the location of that real quick. And it looks like it could have done some damage. It's showing up red on the pager. Oh, it's a pretty heavily populated looking area there. Lots of cities around that quake in the Philippines. Another one of those quakes in Western South America was deep. Make it 2. A 109 kilometer depth quake, followed by a 177 kilometer depth quake, happening about 3.5 hours apart. I would invite all of our viewers to visit our own website, smAshomash.com. smAshomash.org will redirect you. You can find our social media there behind that little drawer, as well as links to our forum and our merch shops. Check those out. Thanks to Smash staff for posting a recipe. We've got a new thread at smashomash.com/forum, recipe sharing. So today we'll be making chili, and we'll be adding a couple little extra add-ons to this recipe here. We'll be dicing a fresh tomato, half a large red onion, also a poblano pepper and a green pepper, to add a little depth, and there will also be mushrooms on the top layer of this. And this is designed to partially cook in a crock pot here. So if you'd like to check that out, smashomash.com/forum. Also follow us on Instagram. If you don't follow us on Instagram, you may not see images like this, although our patrons saw it too, as well as Twitter followers. We did enter into a period of geomagnetic storm, and some auroras were generated from that. It looks like northern Minnesota may have seen some auroras, as well as North Dakota. And there are the magnetic perturbations on the ground. And there's the Geospace Magnetosphere movie snapshot. Instagram.com/smashomash. exclusive content there, and lots of exclusive content here on YouTube. So thanks everybody who tunes into the live premieres, etc. And thanks for leaving comments, Kathy Garden. Those are lengthy comments. I will get to those momentarily. First, I would remind our viewers to press like and subscribe on YouTube. Otherwise, the Smash News Network may continue to burn. And we don't want that. So press like and subscribe. Share on your social media. Tell your friends, your foes, your science noobs, and your science pros that the content does not indeed stink. Smells good to me here at the Smash News Network. Anyway, hopefully you've already pressed like and subscribe and pressed the notification bell. Maybe you've even shared on your social media. If you haven't, just pause the video. We'll be here when you come back. Now, this smAsho stream was streamed live to twitch.tv/smAshomash. Thanks to our new followers over there. Cheers. Twitch.tv/smAshomash. Twitch has a great mobile app, and they're a fantastic live streaming platform as well. Again, our URL at Twitch is twitch.tv/smAshomash. We don't always stream live to Twitch, but we just like the live streaming platform. And why not? When we could just record a video and make it exclusive, why not put it in more locations? So today's cosmology segment will be short but sweet, talking about the great Annihilator. And before we do that, the real stars of this video are our patrons. So consider becoming a patron at patreon.com/smAshomash. We have not updated the credit crawl yet for February. We apologize for that, but it will be coming soon. It all has to do with banking. Thanks again to our patrons, patreon.com/smAshomash if you would like to support the content. We need your assistance to accomplish our goals in the year 2021. So the Great Annihilator is referred to as a microquasar, which could be something like a star orbiting a more massive star. One of them is a massive radio source, sometimes referred to by some folks as a black hole. And the reason it's called the Great Annihilator is because it appears in gamma ray spectra. So the reason it's called the Great Annihilator is because when positrons and electrons, when positrons and protons meet each other, as well as electrons and anti-electrons, they annihilate each other and release massive amounts of energy known as gamma rays. So the Great Annihilator is an interesting object. It's located at about 16,000 light years, and it's likely in between you and the galactic core. So one of the many, many very powerful objects in between you and the galactic core is the Great Annihilator. It is a massive radio source being orbited by an even more massive radio source. And here it is in Chandra, in X-ray frequency. I don't think it shows up on the XMM. Oh, it's on the XMM also. And we'll show you also on the Fermi. So here it is on the Fermi, and that is gamma ray spectra. And you can see there's the galactic core. You can see how close that is to the galactic core. Again, there it is on Chandra. The Great Annihilator. Perhaps have a read about that if you like. That's today's cosmology segment. So we haven't seen any solar flares, no coronal mass ejections or anything going on right now. The main point of interest is that sunspot in the southeast. We'll get to it. No proton strikes on the magnetosphere. And let me just check the life of the stream. Again, thanks Kathy Garden for leaving comments. We will get to those, I guess, after the video, because there's frankly too much for me to read while doing a live stream. Next, we'll look at the real-time solar wind. And we have seen geomagnetic storm conditions. The solar wind speed has actually subsided. I would expect this to come back up again, and NOAA would tend to agree with me on this. Solar wind density only reached under 20 protons per cubic centimeter there, just under 20. At the peak density before the high-speed portion of the coronal hole wind stream showed up. And the highest speeds we saw were around 530 kilometers a second. That has subsided a little bit. I would expect this to come back up in the next 24 hours a little bit. We may see more geomagnetic unrest, or perhaps another mild G1 geomagnetic storm. Current conditions are 490 kilometers per second for the solar wind speed. Solar wind density, 7.39 protons per cubic centimeter. And there you can see the KP index now down to geomagnetic unrest conditions, a KP of 4, having been at, my nose is itchy. KP of 4 having been at a KP 5 for about 6 hours there. The KP index is a measurement of global geomagnetism, and thanks new viewers for tuning in. Here's a geospace magnetosphere movie, and we're going to actually show you the density as well here, as this incoming high-speed coronal hole wind stream has created some dense regions around the planet. So we're showing you density here in protons per cubic centimeter. That's 4 hours of data. And it's based on the space weather modeling framework. And it's courtesy of University of Michigan. So there's 4 hours of data on density. And here's pressure. Let's bring that to the beginning. So we've just seen the geomagnetic storm conditions taper down into geomagnetic unrest. And nobody was even really expecting to see a KP of 5. So those conditions may return. Don't be surprised to see the KP go back up to 5. So here are the geospace ground magnetic perturbations. We're looking at changes in the Earth's B field here at the surface. And I would note once again, lots of ground magnetic perturbations happening here in this portion, which is the area south of South America. An indication that perhaps the south geomagnetic pole is split as well. Now, it's fairly well known that we've got 2 north geomagnetic poles, one over northern Canada and one over Siberia. Have we already got 2 south geomagnetic poles? That is the real question. There are a lot of people sailing around the Arctic on boats and so on, and those people have compasses. However, there's practically nobody sailing around Antarctica. So, I'm just putting that out there as a possibility. I do not have access to swarm satellite data or any ground-based magnetometers on Antarctica. I just wanted to put that out there, because it is what you would expect to see sometime, assuming that the polar excursion is continuing to intensify, as many YouTube channels would like you to believe. If it is intensifying, it would be likely for the south geomagnetic pole to split also. So as far as weak spots in the magnetosphere, we do have one here, the South Atlantic anomaly, but we've also got one down here now, as the South Atlantic anomaly split as well, and we've got a South African anomaly. So these could all be indications of the continuation of the geomagnetic excursion. And I just wanted to cite this possibility, as you can see more magnetic perturbations down here than down here where the geomagnetic pole actually is. So, and again, delta, I say this daily, delta B would be changes in the Earth's B field. Whenever you see delta in science, it means change in. Now we've brought up the 30-minute aurora forecast here, just to show folks where auroras were likely. You may have missed them already, as the geomagnetic storm conditions have subsided, but they may come back. And this has to do with Earth's geomagnetism as well. It does give us some insight into where the poles are located. The South Geomagnetic Pole definitely does appear to be closer to Australia than to the geographic South Pole. or at least somewhere in between, quite far from the geographic South Pole, let's just put it that way. And it has indeed left the Antarctic continent. It's someplace around here. And here are the low readings on the GOES magnetometer as I actually forecasted yesterday. See those low highs and low lows? I forecasted those yesterday. That's 3 days of GOES magnetometer data. And you're seeing spiky readings in here also, and that's typical of an incoming coronal hole wind stream. Let's take a look at the current sheet. Here's the current sheet broken into polarity. North is green and red is South Pole polarity. And the Earth is solidly in the South Pole current sheet. I would expect us to remain there, although it could suddenly change, especially with the possibility of a sunspot. Keep in mind the data is nearly 2 hours old and can change with absolutely no warning. Here's a line of sight field plot, which also shows you the solar magnetogram. And this is showing you the sun's B field, so you can see a visual representation of delta B for the sun. I hope that helps. Here's the coronal hole line of sight plot. And you can see one South Pole-oriented coronal hole there in front of that likely sunspot or sunspot group in the southeast. And here is a magnetic field diagram of the solar corona, the sun's atmosphere. A chaotic place indeed. Is it more chaotic or more orderly than the Earth's atmosphere? Speaking of the Earth's atmosphere, here's a diagram of it in kilometers. And that red F over on the right, that's the F ionosphere layer. That's where the GOES 16 makes its measurements. And here is another diagram showing you Van Allen belts, as the next section of the video will be about electrons. And the inner Van Allen belt is the Van Allen belt through which your GPS satellite must transmit data in order to give you a GPS signal. So we do see some charging hazards here north of the equator, around places like Mexico and some Central America. No major ones. And electron flux levels are actually fairly low here. There's the 3-day chart of the GOES electron flux. We briefly reached into electron flux warning there yesterday, and our patrons would already be aware of that. Here's the 1-year chart of the relativistic electrons to put that into perspective. And here's me vanishing. And this is actually looking a little bit anomalous. I'm going to let this play through a second time here. We see significant electron flux here over North America, as well as essentially some wobbly blobs of electron flux. And here's the forecast model. And you can see the forecast was missed here. I think this was actually that's actually exactly where my forecast was yesterday. Go check yesterday's video if you don't remember. I'm pretty sure that's about exactly where I forecasted it. In any case, NOAA expecting an increase in the electron flux in the next couple of days. I would tend to agree with that, although that won't happen until the coronal hole wind stream or wind streams subside. Here's just the ionosphere layer. This is courtesy of Australian Government Bureau of Meteorology. Ionosphere looking slightly anomalous here. A little bit of an odd shape to it there. It is southern hemisphere summer, though, remember, folks, making the sun, relatively speaking, closer to the solar rays are more direct south of the equator. In any case, there's the latest image, 11 o'clock Universal Time. Next, doing some meteorology stuff. Here are the jet streams. This is on nullschool.net. Perhaps join their community. Oh, we've got some backward jet stream here over the Western Pacific and Indian Oceans once again, as well as a very chaotic jet stream scenario in the Southern Hemisphere and the Northern Hemisphere. Here are the jet streams of the Western world. Extremely chaotic, especially in the South. Look at the jet stream over South America. It's completely broken up. We've got a massive anticyclone in between Greenland and Canada. Extreme meridional jet stream bends over the Pacific Ocean. Doubled up jet stream over the Atlantic Ocean. And 2 cyclonic rotations. Actually, here you've got an anticyclonic rotation as anticyclones rotate counterclockwise in the southern hemisphere. And then you've got a clockwise cyclonic rotation out here right under the South Atlantic anomaly, interestingly enough. And looking at the U.S. Doppler radar map, we're expecting some snow in the northeast. I won't do a forecast as there are 16,000 other YouTube channels doing so. Hi, other YouTube channels forecasting snow. We really hope you understand atmospheric physics. Cheers. Next, looking at pressure cells. Here we're on windy.com. And let me just check the life of the stream again, just to make sure everything is good to go. And it looks like it is. So here's where pressure cells are now. There's going to be a low pressure system moving up the east coast of the U.S. I wasn't zoomed fully out. I would also note once again, massive high pressure dominating the entire northern hemisphere. Look at the high pressure. The whole North Polar region is high pressure, and the whole South Polar region is low pressure. Quite interesting indeed. And let's move this forward. So that low pressure system looks like it's going to skirt up the coast very quickly. There's where we expect things to be at 12 noon Eastern time tomorrow. Dueling low pressure systems in the North Atlantic. And look at all the high pressure extending all the way from the North Geographic Pole to Pennsylvania. Really all the way to Africa. I mean, high pressure all the way up to there. Massive high pressure. Are you under pressure? Have you had your protons today? Next, looking at the cloud layer, since it's too dark to see it, here's the water vapor map to go along with it. There's the cloud layer once again, and there's the water vapor. And the reason that low is going to move up the coast so quickly is because of this south to north flow. This dry, massive air here is going to not allow that low to stagnate. And it's going to give it a little bump. Hey, thanks Smash Team for not promoting fraud and viewing our videos. We're the gold standard of solar forecasting, apparently. Who would have guessed? This is what happens when you immerse yourself in the data. You find yourself down rabbit holes that you weren't even expecting to be in. And that's part of the reason why we have a channel. Who knew we'd be able to forecast coronal mass ejections? I didn't. Until I found myself forecasting them, and now here I am. And now here I'm vanishing. So anyway, thanks Smash Team for tuning in. Remember to press like and subscribe on YouTube, share with your friends, foes, science noobs, and science pros. Press the notification bell. You may know when we're creating a video then. And we may do another live stream today. Not sure yet. Certainly what I am sure about is that we've got bonus of features, as we've got to take a look and see if we see Umbre. Will we be the first to announce the latest Sunspot? 2802. Will it be a thing? And the answer is It's too early to say. So I don't see any dark ombre there. And here's the colorized magnetogram. So there you go. No ombre yet. But don't be surprised if that is a sunspot. My new guess is that it is not a sunspot. And we've got some close-ups of that area on HelioViewer to show you here, starting with 304 angstroms. And I know there are some other filamentary things going on as well. We may make another video just with solar close-ups. But in any case, there's the southeast limb. Leave us a comment. Let us know if you think it'll be a sunspot or not. My new guess is that I don't think it will be a sunspot, just an active region. Here's 131 angstroms. And like 94 angstroms, this takes 10 images per minute instead of only 2. 94 and 131 are specifically formulated to study things like solar flares. Here is 211 angstroms. Great view of the filaments in between the coronal hole and that active region. Not quite as good as 171. So we'll show you that after 193. Here's 193. Another wavelength good at showing coronal holes. Here's 171. My personal favorite wavelength, 171 angstroms. And that is ionized iron. And those brightest spots are lots of ionized iron. I believe it's iron 18, something like that. And let's close things out with a full disk view in 304 angstroms ionized helium emission spectra. Thanks for tuning in. Remember, stare at the sun, don't drink, and if you do drink, don't drive. And since it'll never be now again, welcome to the Neo Renaissance. May that solar wind be at your back. One last thing. There was a filament. I saw filamentary movement right here. I believe that splashed back down into the chromosphere. I did not see a coronal mass ejection. See you next time.